Hey, good afternoon. Hi. Hi. Yes, thank you for staying. And I'll talk about eBPF, and I hope I'm not gonna alienate you or send you away, because I didn't realize this is a developer conference, and I'm big on infrastructure and getting into the kernel. So I hope I'm not gonna bore you, or maybe you can walk away with some new information, something to try at home. But be careful because we are talking about the kernel here, so let's be careful. So I'm Alessandro. I live in Amsterdam, Italian. I'm a father, husband of my lovely wife, in my best friend, of course. I'm a CNCF ambassador. If you don't know what is the CNCF, means the Cloud Native Computing Foundation. So it's a daughter of the Linux Foundation, one of the oldest and biggest open source foundation in the world. The Cloud Native Computing Foundation specifically takes care of the cloud native open source projects. There are now 179. It started with one, Kubernetes, if you ever heard about it. The foundation was born to manage the Kubernetes project, and then it became kind of the umbrella for a lot of cloud native technologies. If you have an open source project, you want to boost it and make it going worldwide, you probably want to talk to CNCF, donate your project, and become part of the foundation, of which I am a humble ambassador, as in I organize the Cloud Native Meetup in Amsterdam, so in Amsterdam and in the Netherlands as well. So if you want to join, if you want to talk about Kubernetes, we are a big community, everybody's welcome. I used to work at Microsoft. I used to work as solo, and that's why, please notice, that's my first day of unemployment, but I'm still talking about those technologies, which is Istio and BumbleBee is an eBPF project I'm going to talk about. So even if I'm not working for them anymore, these are open source projects. They are not tied to any commercial entity. Actually, we are looking for more contributors to get more knowledge about eBPF out there and to help you writing awesome eBPF programs. And I'm working on the next big thing. So please come to talk to me if you want to know more. I'm working on this new startup idea, and it's going to be super cool. So brace yourself. We're going to go into the kernel, right? So it's a dangerous place. It's a very fast place. It's as fast as it gets, right? So, but I'm gonna show you how the kernel execute code and what's going on and how to tweak it and fool it into running our own code. So who is a kernel developer out here? One? Oh my God, okay, then I have to be careful what I say. I wasn't expecting that, but yeah, please correct me if I'm wrong, but okay, cool. The kernel is very old, right? So I'm 47, actually, I'm so glad I get to talk about this stuff. I remember compiling the kernel, right? So I remember whenever you had a new network card or a graphic card, you had to actually recompile the kernel slowly. It took hours. But those days are over. I mean, I'm not 18 anymore, you can tell. But it's still fun. Actually, I think it's more fun because you can dynamically load modules into the kernel and have fun with it. Now, eBPF, the technology I'm going to talk about, it's a new way to actually make your kernel work for you and do things that are more interesting than just what the kernel provides out of the box. So what is eBPF? So I'm going to try to explain it in 5 levels, right? So I saw a lot of these 5 levels YouTube videos, so from 5 years old to kernel developer, of course. So I'll try my best to guide you through to the kernel inner working. So first of all, eBPF is, for me, cheat code for the kernel. Don't try these cheat codes. I tried them. They don't work anymore if you play GTA 5. So it's kind of, eBPF is it's a way to cheat, right? So get the kernel to execute code that is not per se approved or vetted by the kernel developers, by the maintainers, but still safe and close to the metal, right? So, and this is why, right? So this is everybody knows, I mean, you have to go through a very, very complicated process. Recently, Rust, the programming language, started to show up in the kernel code base, and that took years, right? So you have to get this guy to say yes, right? To tell you, yeah, I think it's a good idea to get this code in, but it tends to be quite a guy, right? So Linus Torvalds is still the guy who owns and controls more or less the kernel process. So we live in a world, cloud native and all this innovation. You can't wait 5 years to get some code in the code base. You can't wait that long to get your features in the kernel. So what's going on? What happened? It happened that they started to introduce slowly, like piece by piece, a mechanism to execute code within the kernel space. If you don't know much about Linux, Linux is basically divided into two realms, right? So two big memory space and big execution space. One is the kernel space, which is responsible to interface with the drivers, with the physical hardware of your machine, and the rest is the user space, where everybody lives, your browser, Visual Studio Code, but also every program you execute, Bash, for example, lives in the user space, and everything else is kernel space. So how do you interface these two realms? And that's why eBPF was born, as a kind of reaction to this slowness and difficulty in getting code into the kernel. So, and now you can experiment much faster. It's the same kernel. You don't need to reboot. You don't need to recompile. You don't need to do anything fancy. You just load code into the kernel, and the kernel will happily, provided that you pass the necessary test and verification, it will be happy to execute it. So, little trivia. So BPF stands for Berkeley Packet Filter. It started as at Berkeley, at the university, 31 years ago. So pretty long time ago. I don't remember when it came out. I mean, I'm not that old. And it was purely a method a kernel feature to manipulate network traffic, right? So as packets come into from the network stack, the kernel, the BPF stack was invented to provide, for example, network packet filters and firewalls and so on. And then eBPF is built on top of that, but it's really, really quite a different beast, right? So it just has the name of BPF, but it's it's not completely different, but it's definitely has a lot more application than just the packet filter. So it's not just a mechanism to get something done when a packet arrives to the network card, but it's a generic mechanism to execute code, arbitrary code in the kernel. So if you ever use TCP dump, there's actually BPF, and it's been around for as long as I remember. So I used it when I was a kid, and I still use it. Level 2, and maybe this resonates with some of the front end in the audience, if there is any. So eBPF is kind of a JavaScript. What is JavaScript to HTML? Like executing code in response to a click of a button or other events in the browser. eBPF is exactly the same. So it executes code in response to events provided by the kernel, right? So it's a way to augment and extend the kernel into doing something useful to you, to the user. And it's a programmable, secure interface to the Linux kernel. So you don't need to understand too much about how the kernel works, but you just have to know what kind of events the kernel produces, and use it and manipulate those events, and maybe also use some data structure that you can use when you use eBPF programs. So it's an event-driven kernel level programs, but they are user space. I mean, they are made by users, but executed by the kernel. So the kernel, it's a monolith, right? So, well, it's made of, there are modules, but the kernel has a thing called syscalls. So if you want to know more, of course, there's a lot to talk about. System calls are a way to ask the kernel to do something. It's a interface, and the API of the kernel is based on these syscalls, and these processes do call this API to, for example, write a file, read a file, analyze a packet from the network card, or send a packet down to another host or to another process in the same host. So this is the core of eBPF, is event-driven programs that are executed whenever something happens. So imagine there is a file open, there is indeed like a packet arriving on the network card. eBPF, the kernel can trigger those eBPF programs on demand whenever you need. And it's all about the hooks. So the hooks are these functions. It's also, and they can be, of course, like a TCP or UDP or IP-based hooks that trigger eBPF programs. So to get into what really goes on, let's follow the journey of an eBPF program. So you have an agent. So it could be you, like creating a C program. Most likely, if you use Kubernetes, it's probably Cilium or another CNI, like Calico, that creates those programs. Those programs are loaded, so are first compiled into bytecode. What is bytecode? Is this kind of meta language based on assembly, which are compiled from C, that's C over there, into this bytecode. The bytecode is loaded into the kernel by calling a syscall, BPF syscall, and they are passed to the verifier. The verifier makes sure that the programs are respecting the boundaries, the guardrails of eBPF programs. So, for example, they cannot, and this is a limitation of eBPF, you cannot do anything you want, right? So you gotta have some respect for the kernel, because if you crash the kernel, it's game over. The whole host goes belly up. So there are some guardrails. For example, you cannot use infinite loops in eBPF programs. That's forbidden by the verifier. So if you have you cannot have unconstrained loops. You have to make sure that you know exactly how many times that loop is going to run. So there are quite a few. Of course, also the size of the program is fixed. So it's not exactly, you cannot run crypto miner, you cannot run, I'm not sure if somebody ever ran Doom as an eBPF program. Maybe somebody did. I don't know if you can stay within the rules of eBPF, but you get the idea. So you can do small programs, very specialized. For example, setting up routing for Cilium in Kubernetes. And so after the verifier, when the program is approved by the kernel, then you get a just-in-time compiler, which compiles down this bytecode in actual instruction for the CPU. So it could be ARM, could be AMD 64, but it's native to the CPU architecture. So it gets very fast because it's, of course, it's assembly, and it gets executed by the kernel over whenever the hook that triggers that is done. This will not be that useful if you have no way to exchange information between the user space and the kernel space. So that's why eBPF introduced the idea of BPF maps, which are simple key value stores where the program can inject values in there, and the user space program can read from that, and can use it to exchange information. It also works the other way around. You can inject data into the BPF maps, which can be executed, used by the BPF program, and that's when the programs are executed, when there is a hook. Could be a kernel probe, could be this LSM, the Linux Security Module, which is very important for security applications, or can be wherever there is a connection through IPv6 or IPv4 and so on. So this is the core of how eBPF works. So how do you write this? There is a bunch of tooling, right? So tool chains that can help you write eBPF code that will be eventually loaded into the kernel. So one most popular is BCC, which is this compiler for BPF programs. There's a bunch of profiling and performance-related tools based on BCC. It's not exactly the most easy way to write program because it's composed of two parts, right? So if you can see, if you maybe you know Python, maybe it's something that resonates with you. So this is a Python program. BCC is a Python wrapper for BPF programs. The BPF program itself is embedded in a string, so the whole C code is all in there, right? So and it's actually loaded into the kernel by the BPF syscall. So you gotta write two things, like the Python loader, the Python user space part, and the kernel part. And it's not exactly the easiest to maintain. These are you create the maps, of course. So and the whole point is that I'm going to show you a way to do this better. So you also have to manually manage the maps and load them and attach the programs to the events and take care of the whole mapping by yourself. These are the codes you can do. Of course, you can read, look up, delete keys in elements in the keys, and there are many types of maps. Can be hash, arrays, and so on. And I'll show you. There's another way, of course, which is this compile on run anywhere. It's another tool chain to build BPF programs and to inject them in the kernel. So it's more for C, C++ developers, and I'll show you even today. I'm going to show you another project, which is BumbleBee. So this is the summary. So a BPF program is a set of instructions written in its own language, this bytecode pseudo C. It's a subset because you cannot do everything you can with the regular C. That's why we call it its own language or a subset of C. But eventually it's translated into bytecode, kind of a subset of assembly language, made safe in kernel VMs, executes this, and is compiled and is created by things like BCC or libbpf, which is a C++ library to write eBPF code. And what is it for? Why you care? Because it's revolutionizing how we do computing. Who has an Android phone over here? You are running eBPF. Who has a Facebook account? All your requests to Facebook actually go through Catran, which is a very fast, very efficient load balancer written in eBPF. It actually was invented at Facebook and then donated as an open source project. But also observability. So you can get exactly how many performance counters. You get it straight from the kernel, exported to Prometheus, and you get perfect visibility over what's going on into your Linux host, and by conversion also in your Kubernetes clusters, because Kubernetes clusters are just a bunch of Linux hosts eventually. And it's also for Windows. So Microsoft also is porting large parts of eBPF down to the or up to the Windows kernel. And security, of course. So imagine being able to be notified whenever anyone creates, modify a file under etc. You can do it with the eBPF because that creates an event, file descriptor, file open event that can be intercepted by eBPF programs and then alert whoever needs to be alerted. So indeed, Android running Linux, of course, also use eBPF to, I'm not sure about it, I'm not an expert on Android, but I know that use it for performance counters and to measure the traffic. If you want to know how many gigabytes you're transferring, you can just ask the kernel, right? So you can just keep count of those packets and just provide the user with a count. Netflix, also a big investor in eBPF, as is super cool. They just released it, BPF Top. It's like if you know what is top for Linux, just shows you the top processes that use CPU and RAM, and so BPF top is the same for eBPF. But there's an easier way, so you don't need to go crazy and write all this stuff by yourself. So BumbleBee is a project born as solo, it's open source, and is a way to make your life easier when you want to quickly experiment with BPF programs. So if you know what Docker is, and if you're used to Docker build, Docker run, Docker push, BumbleBee aims to be exactly the same experience, but for eBPF programs. So as the same set of commands where you can use to package those eBPF programs, push them to an OCI, Open Container Initiative. So if you don't know what OCI is, if you know what a Docker image is, a Docker image is in fact an OCI image. It's just a standard for defining container images. So how does it work? So you do just a B, you install BumbleBee, simple program, and you do B build. That will spin up a Docker container with all the tools, all the LLVM and CLang to compile your code into the bytecode. The bytecode is then packaged into OCI image. And once you have everything in an OCI image, then sky's the limit. You can push them to a registry. You can pull them into your pods and have your pods running BumbleBee executable, the shim that execute the bytecode, and that will load the BPF program in bytecode straight into the kernel. So how does it work? This is to build an image, and now we want to run that image. So if you don't have Kubernetes, you want to just run it on your machine to test if the code is proper and it works. You just do brun. It will download, if it's not present on the node, it will download the Docker container, OCI image, will load that program in the kernel, and the B, the shim, the executable, we also take care of the reading and write to the BPF maps, and eventually, because you read from the maps, you can actually export it as a Prometheus metric. So the B runtime will automatically export whatever you want from the map into simple to consume Prometheus metrics. And that's where B is also so cool for observability, because you can just use it to gather the metrics out of the BPF maps and into your metric server. So it is Kubernetes. I wrote it, but I don't know how to pronounce it. But you get the idea. So can be running Kubernetes? Definitely, it can. So the BumbleBee pod runs the B executable and will load your eBPF programs in the kernel, and will make sure that they are running and it gets the data out of the pods, out of the BPF map. So that's how it works in Kubernetes. Of course, this Cilium will use the BPF API to load the thing. So little demo. You can go to academy.solo.io. It's a great resource. It's free. And you can learn about eBPF. It's the shortest demo ever. I have 3 minutes, but I think I'm gonna, come on. Of course, because well, we need to wait. It's usually less than a minute, so I know there are no questions possible, but I'll keep talking until this is done. But what is really important in eBPF is everywhere, right? So we are seeing an explosion. The last couple of years, they've been all about understanding how can you do almost everything with the eBPF, load balancers and more performant replacement of IP tables. IP table is this very old mechanism, which is also the one that powers almost every Kubernetes cluster out there to do routing within the Linux kernel. And if you ever look at IP tables, they are quite difficult to understand, right? It's bit of a mental load to get really the idea of what IP tables do, and they are also quite slow, at least is understood to be quite slow. So eBPF, and specifically Cilium, which is an implementation of eBPF as a container network CNI, container networking interface for Kubernetes, the idea is to replace IP tables with eBPF programs. Whenever you have a packet, instead of going through the list of rules, that is IP tables, you can just run an eBPF program that does that routing for you. So that's the power of eBPF for container networking. And while I did that, at least this started. So that's the second one, of course. So what I want to do, is to install BumbleBee. So this is a simple one-liner. It's nothing complicated. And then it's a very simple user experience. You do B init. Of course, there's only C possible here because we want to include Rust and other languages, but for now we only have C. So it kind of guides you through a tutorial, to an easy experience for users. So let's say we want to do a network program, right? So we want to analyze the network, and we want to and also BumbleBee introduced the idea of ring buffers, which are a more efficient way to store information, but we'll stick to hash maps, and we want to do print, right? So yeah, print. And then the file location is probe.c. So now I have everything. So from nothing, he created this probe.c, and he did the BCC and everything. So and now you can see this probe.c. So it's a scaffolding. It's a templating engine for writing BPF programs. So this is the program, and you can easily run it. You can see the top. You have to include the Linux headers and the BPF library, this C, of course, and it does something like, and you can extend it. You can also do it yourself, but let's say that I want to do this. You can do this, of course, and then compiles the BPF program into the probe.o. And also builds the Docker container for the OCI container for that I can then push to my local Docker registry. Takes some time. Well, and there's an error, so that concludes the demo. Not in a very glorious way, but I can assure you, with a little more time, it will work. So there are some resources out there. Of course, one of the best is the eBPF guide. There's a lot of isovalent and solo.io website. And of course, eBPF also has its own foundation, eBPF Foundation, with a lot of resources out there. And I thank you very much. And you can find me in many places, but also around here. I'll be happy to talk to you about eBPF. Thank you.